Okay, so what I want to do in this video is to point out a very neat and very important connection between the directions of E and B in the solution to Maxwell's equations that we found several videos ago and the Poynting vector. So I've shown you the solution here. Remember, we had an electromagnetic wave that was propagating in the x direction. That's what we found. And it had an EY and a BZ. Okay, the BZ is pointing out at you. And the wave was moving in this direction. But at this one moment in time when we took a snapshot of it, the EY, which up here was pointing up some ways over, half a wavelength over, the EY was pointing down. And at the spot where the EY was pointing down, the BZ had flipped sign also. So the BZ, instead of pointing at you, as was the case over there, was pointing away from you towards me. So this was the solution that we found. This is what we found just by following our nose and solving the equations. And now let's work out what the Poynting vector is. And let's remind ourselves what the definition of the Poynting vector. So the Poynting vector, which we symbolize by S, the Poynting vector is the definition of it, which we learned previously, is E cross B, and then there's a constant here, which is mu naught. And so let's work this out. E cross B. Well, so I take my right hand and I go E cross B, and look at that, the Poynting vector is pointing this way. So right here at this location, from this E and this B, I have a Poynting vector which points in this direction. So again, let me use my right hand, E cross B. This time E is pointing down, B is, so I curl my fingers in the direction of B, that means from you towards me, and again, Poynting vector this way. So here also, Poynting vector points in this direction. So this tells you that the story hangs together, okay? The electromagnetic solution that we found described waves going this way. And the Poynting vector points this way. And what that means is that this electromagnetic wave is carrying energy this direction. It also means, by the way, that if I had started out constructing a solution in which I had, let's say, the EY exactly as it is, but suppose I had chosen at the beginning of my derivation, a bunch of videos previously, suppose I had chosen that at the spot where EY points in the positive Y direction, BZ, instead of pointing in the positive Z direction, suppose I made BZ point the other way. Suppose here my BZ was pointing not out at you, but instead pointing towards me, away from you. Then I would have taken my right hand out and I would have gone E cross B, and the Poynting vector would have pointed that way. And in such a solution, this B would have been in the opposite direction also, and here too, when I would have done this, and the Poynting vector would have pointed this way. So if I had chosen my BZ to point the other way, I would have then followed through the math, and I would have found that I had a solution to Maxwell's equations as long as the whole pattern was going that way. And you should go back and check the derivation and see that that's true. So once you realize this, you then remember that realize that you can use the definition of the Poynting vector to always tell you the direction in which the wave is moving if all you get is a snapshot of the E and B at one time. So for this wave, as drawn, E like this, B like this, use my right hand, Poynting vector this way, this is a wave going that way. I don't have to go back to Maxwell's equations, write out the whole derivation that we did, and see that it all hangs together and it solves Maxwell's equations so long as the whole pattern is moving this way. You can just use the Poynting vector to remember that, to rederive that. Similarly, if you're ever on a test, for example, given a wave which is set up with the B the other way, you use the Poynting vector to work out that wave, although you were just given a snapshot of it for it to be a solution to Maxwell's equations, that other wave had to be going that way.